Very good evening, Jai Bhim, to all the participants and myself, Dr. Ajay Kumar Koli. And I would like to welcome all the participants and respected speaker for this session, Professor Dr. Samantha MacBride. Today is day second of our SARA Data Science Summer School, and it is a 5-day program, which is especially for the participants who are pursuing PhD or practicing researchers. And today, in this session, we are going to talk about the importance of the visualizations and to understand the basics of the data visualization. And to share insights about this topic, today we have Professor Dr. Samantha MacBride. She is a PhD in sociology. And after that, she worked with the discard study and sanitation with government of USA in New York. She is the author of a book related to the discard studies. She is like a person who is on ground know the realities of the sanitation, the discard studies, and how big and how to manage the issue of the discard. And thank you, Professor, for joining us. And right now, she is an adjunct professor at Prof College in New York. And we are very, very lucky to have you today with us. And with this, ma'am, platform is yours. And kindly, yeah, you can start your presentation now. Thank you.
Thank you, Dr. Koli. Yes, and good evening, everyone. I'm honored to be here. I'm Samantha MacBride. I teach at Baruch College in New York City, and I'm here to talk to you today about data visualization. Oops. So today, after some acknowledgement and thanks, I will talk about some historical examples of data visualization because it's been around for a long time. And then we'll get into defining what it is and what its core elements are. We can finish up with a few examples from my own research on waste and discards, as Dr. Koli said, and then I hope we can have a discussion. So I first want to start out with some thanks to people who have helped me in putting this together.
Sorry to
Yes.
The slides were not visible now. I'm sorry to interrupt.
Oh no. Okay. So you can't.
One second. For participants can see that. Only for me it is not visible. One second. Give me a second. Maybe I did something wrong. What did I do? Yes. Now it is visible. Thank you. Yeah, please continue, Professor. Please.
Okay. So first of all, I'd like to thank Mr. Tommy Chowdhury, who works at John Snow Incorporated, who actually put together a lot of this presentation. I want to be honest about this because this is not, as I'll get into, an area of expertise of mine, although I use data visualization all the time. Also, I'd like to thank Dr. Gang He, who is another professor who teaches with me and who gave me some great ideas for this. And most of all, Dr. Kiran and Dr. Ajay Koli for having me. I'm thrilled to be here, and I'm very grateful. I also want to acknowledge that the house that I live in and where I am now occupies the traditional stomping ground of the Narragansett Nation and the Niantic people. These are indigenous people to North America. I honor and respect the enduring and continuous relationship between the indigenous people and this land that I'm on by teaching and learning more about their history and their present day communities, and by becoming stewards of the land that we too inhabit. So I mentioned that my colleague worked at a company named John Snow Incorporated, which is a global research consulting company now. And it's named after someone who lived in the 19th century in London, named John Snow, who was, at least in the Western tradition, an early example of data visualization. And what he did was there was an epidemic in London of cholera, the disease cholera, and it was believed at that time that it was transmitted through gas that was coming from swamps, and that was holding on to the contagion. John Snow looked into this and he mapped out the cases of cholera in the neighborhood. And what you're looking at here is a map where the darker spots show all the cases in which families had cholera. And from this type of research, he found that the cases were clustered around one well that was in that neighborhood, one water well. And so he began to argue that it was not transmitted through the air, it was transmitted through the water. And that argued for a different way of approaching this public health problem. So another historical example from 20 years ago is shown at right. This is the cover of a report that I wrote for the Department of Sanitation in New York City way back in 2004. As Dr. Ajay mentioned, I have a PhD in sociology. I worked in the civil service of the city of New York. So this is the government of New York City for 25 years, and now I teach at a local public university. This is also a city university. I also work with a community composting organization in New York City. And as mentioned, my specialization is waste management. I've been studying that for my entire life. I am not an expert on data visualization. I consider myself a user, which would be similar to all of you. Um, but I've used it enough to say I'm not perfect at it myself, but I use the principles of it all the time. And this cover of this report was an early example of data visualization that I proposed to my supervisor when I wrote this report, Robert Lang, and he approved it. And so what it shows here, this report is all about the fact that recyclables have a market price that fluctuates. Sometimes they're worth more, sometimes they're worth less, right? And I wanted to show that on the cover of this report. So I've got the fluctuating market prices. The background is a photo of recycling that was taken at one of our facilities. The y-axis here is the dollar value, the market price of 1 ton of recyclables. The x-axis is the year, and if you're wondering why these dots are here, I finished the cover in late 2002, and I was predicting the future based on other research for prices. It took that long to actually publish the report until 2004, which is typical of government. And then finally at the bottom, you may not be able to read it, but it says market value in New York region of 1 ton of commingled metal, glass, and plastic recyclables. I was very proud of this. When I was young, I was proud of this cover. I was surprised that my superiors liked it and wanted to publish it. So that's another historical example of thinking about how visuals can convey what you want to say. So let's just define data visualization and what that is. It's simply any graphic representation of data. That's as simple as you get it. Um, sometimes it's talked about as data viz, and it's talked about very technically, but it can be done in a simple form. It can be done even by hand. I have done that. I've drawn things that I couldn't render on a computer. So that's the definition of it. And data visualization helps to communicate in ways that written information and numbers and tables of numbers just can't. So if you see this graph, you may take a minute to wonder what the letters are, but you probably have figured out that they're the English words for the months of the year in the Julian calendar. And in September, we see something is different. Something is sticking out, right? Literally, it's sticking out of this graph, and it's sticking out color-wise, which we'll get into. And immediately, this is telling you something in September is going on. So there are different types of data visualization that work with different types of software. I noticed that Dr. Ajay is going to be going over something called ggplot, which I don't know myself. Um, but you can use what are called declarative or static data visualizations, and these are, as the name suggests, um, just pictures, maps, infographics, or graphs. Or if you have more facility with IT, you can pursue exploratory or dynamic data visualization, which is more live. And I don't have an example here, but I'm sure that you have seen these on the internet. They include interactive maps that you can zoom in on, or other types of interactive interfaces that users can change the variables of and look at different outcomes. I will say that if you're new to data visualization, or even if you're not, I have found that Microsoft Excel is your first best friend. It's easy to get, and it will take some time to learn not only the basics but all of the advanced things that Microsoft Excel can do in terms of data visualization. But it is very flexible. It can do a lot, and it may be for your needs all that you require for data visualization. But it's certainly a great place to start, and I use it for data visualization almost entirely. But why do we need to visualize data? Why do we need to turn to Excel, for example, to transform numbers into pictures? That's because after looking at a few numbers, the human brain really cannot process them as information. If you're looking at a lot of numbers, especially if you're trying to explain it to people who are not familiar with those numbers, you need to translate them into information. And that one very fast way of doing that is visually. And information leads to knowledge, and knowledge leads to action. And much research is going in the direction of action, of trying to improve the world in one way or another. we Whether or not you consider yourself a visual person or not, everyone processes visual information more quickly and easily than they do text. And there's neuroscience research to back this up. There's something called pre-attentive processing, which means how we interpret what we look at before we're even really fully conscious that we're thinking about it. And the best way to convey this is just with some examples. If I'm show you a list of numbers here, you're not sure what you're looking at. If I tell you to find the nines, it's going to take you a while. You're going to need to scan through each column of numbers. If I simply color the nines and make them bold, they jump out instantly. And anyone looking at this list is immediately going to see the number 9 first. If we're looking at more numbers, longer, a little bit longer numbers, and I ask you to find the outlier, meaning a number that is unlike all of the others in some distinct way, it's going to take you a very long time. But if I show you just some straight lines, you can instantly see which one is the outlier, which one is the different one. So there are attributes to data visualization that that have to do with this pre-attentive processing. And they include length, how long a line is, how thick a line is, how it's oriented vertically or horizontally, whether it's curved. And all of these things in Microsoft Excel and other data visualization packages are available to you to adjust. Another set of pre-attentive attributes has to do with both the intensity of color, the hue of it, whether it's a little different, as well as shape and where things are positioned in space. Again, a viewer can instantly see that these cases are different than the other cases. And this can be used to convey a lot of important information that you want to highlight or emphasize. So these are considered the building blocks of effective data visualization, these attributes that I just went through. They're used over and over again, whether people are aware that they're called that or not. Human beings intuitively figure these things out. Even Jon Snow in making a map and making the cases of color darker so that you could see it on the map. He was doing that. So how do you go about framing your data visualization and presenting it? Well, first you want to ask yourself who your audience is, right? What level of study are they at? Are they a member of the general public? Are they just anyone, or do you have a target audience? Because you want to be putting yourself in their shoes or their mind, so to speak, when you're designing data visualizations for people to follow. And then you want to know what is most important. What is the key piece of information from your data that you want them to know? You don't have to show everything that your data shows. And this is a problem for me because I do that all the time. I want to show too much in a graph. Um, but realize that you can show one aspect of a phenomenon and then either write about it or talk about it um, in more detail. And also how do you plan to communicate? Are you going to be using a web page? Is this for an academic article? Is it for a newspaper article? All of these things are going to go into your choice of which data visualizations to use. And obviously, this is kind of what I said, consider your stakeholders' literacy. This is something that when I worked for government, I told my team all the time, put yourself in the shoes of the person that you're communicating to because they may not understand waste management in the way that we do. They will not know the terminology that we use. And if you don't translate it your message won't come across. So there are a number of factors that go into selecting the right type of data visualization. Um, a bar graph like this is a very common method, but there are obviously a lot of other methods. The first thing to think about is what kind of data do you have, right? Do you have data that is categories, right? So um, data that is red, blue, and green? Or do you have data that is on a scale, right? From light blue to navy blue? Or do you have data that is discrete, meaning it's a number of things out of a total that is fixed, right? And the example here is number of clinicians at a hospital. I was just using colors, so number of colors out of all possible colors, or all primary colors, something like that. And then continuous is for data. For example, if you're getting into the way color is used in graphs, often it's on a continuum of where you don't have an individual color with a name. You have a range that slowly goes from the red to the ultraviolet range. This is a chart that was put together by Mr. Chaudhary that shows some decisions that you can make about what kind of data visualization that you want to use. So you start with the question of what you would like to show. Do you want to show relationships? Do you want to show how things are distributed over time or over some other factor? Do you want to look at the composition? I use this a lot with waste composition. We do research to understand the different categories of waste, and we show them often in pie charts or in stacked columns. Um, or do you want to compare things, which is another data visualization that I use a great deal. I show trends over time in waste, or I compare geographic areas within New York City in terms of their waste. So let's get into some design basics once you've decided what you want to show and what might be some good visualization techniques. I'd mentioned some of the pre-attentive attributes. And here they are again, your font size, and I'll give you examples of each one of these in a minute. Contrast, how two colors or shades contrast with each other. And then there is the question of color, and avoiding the Skittles effect. I don't know if they have Skittles in India. They probably do, right? It's a candy that is all the colors of the rainbow. You don't want to necessarily use all the colors of the rainbow in data visualization because it's too much information visually. So you want to seek out balance, right? The colors here go together. You could imagine decorating a room with these colors. So that's also part of what you're looking for. And and finally, make it really clear what is most important. How are you drawing um, people's eyes to what you want to emphasize? So here's an example of using all the colors of the rainbow. And in addition, too many categories could work on a pie chart. No one is going to be able to really make intuitive sense out of this pie chart except to know that maybe these bigger slices are more of something. So for something like this, we might make a pie chart that collapses all of these smaller slices of the pie that have smaller quantitative numbers associated with them into a little table on the side or a breakout chart, and just summarizes. This says California, Texas, New York, Florida, um, Ohio, Pennsylvania, and then maybe other. Everything else would be other. Um, Using white space is also very effective to separate out items and make them easier for the eye to look at. If you have colors that are close to one another, strangely enough, in our brains, they start to affect each other. So they will seem shimmery, they might seem kind of overwhelming. And if you separate them, that effect goes away. Contrast, this is something again that is very intuitive, right? If you see that the first square with the orange and green says bad contrast, um, there's too much difference between those two shades on the color spectrum, and what it is doing is making it once again kind of shimmery and unclear, as opposed to using either a light or white color or a black color as your text against a color that is more of an emphasized color. In terms of hierarchy, your font size is also an immediate guide to what you want the reader to look at or the viewer to look at first, um, and then to go into details. So if you look at this example where there's a lot of information about penguins, and you put this up on a PowerPoint slide, this is going to be very hard for the viewers to understand, and you might as well not have done it, right? Whereas if you organize the information like this, you break it up, you have headers, and you have a hierarchy, you guide the reader through it very effectively and very quickly. So some more about communicating clearly with charts. First, as kind of mentioned before, you want to use color, but not too much color. So in this case, you've got too many different colors, um, and you've got these units of analysis going on here, whereas the story that you might want to tell is focusing only on CSO2, um, and take it and coloring only that line, as well as taking out some of the horizontal lines, makes it very easy to grasp. Now, obviously, if you're doing data analysis, you might be graphing like this for yourself or your colleagues who are deep in the data analysis, right? And they're going to be able to handle all this color and the number of CSOs that are being presented. But with data visualization, you're always thinking about beyond your colleagues, to the person that is looking at it. Similarly, you want to, and this is something I tell my students all the time, give your data visualization a title. And this also goes for photos that you might, or pictures that you might insert in a written text. You want to tell the reader what they're looking at. Don't make the reader do any work. You want to tell them what this is showing. This is showing not just that men and women have different rates of hypertension, but also that there's been a sharp decline, right? And I'm telling you about the difference between men and women simply by writing men and women here and through the colors, and getting rid of the horizontal lines in the background and adding some data labels makes it much clearer. And all of these things are things that are completely doable in Microsoft Excel. As I mentioned before, use color sparingly, but I think a lot about color. I don't want to say hours, but I spend a great deal of time when I'm finishing my work and getting it ready for presentation or publication on the kinds of colors that I'm using and what they might symbolize or represent to that particular group of readers or viewers. In New York City, the colors of the New York City flag are white, a kind of light blue and orange. And when I worked for the city of New York, I used those three colors a lot because they were consistent with New York City government. Um, in my work in environmental issues, I use the color green a lot if I want to emphasize something that I think is more environmentally preferable than something else. And these are symbolic meanings of color. The color green has all sorts of different symbolic meanings, as I'm sure you well know, not just sustainability. Um, so this is just another example of how using color, but not too much color, can hold on here. Dr. Dr. Ramu Rawat, could you mute yourself? Because there was an echo. Thank you. Thank you so much. Um, Another factor to keep in mind is someone may be printing or photocopying something that is in color, and you want to think through how is that going to come out in black and white, right? So in on the left, it would be in black and white. It might be very hard to distinguish among these parts of the pie. Whereas if you're using shading as opposed to color, it's going to survive black and white. Another thing is people who are colorblind. I had an employee who told me only at the very end of his employment that he was colorblind. And I had been asking him to make graphs and charts and showing them to him without ever realizing that. And he was actually using assistive technology to read the colors. So that's another thing to keep in mind when you're working with color. Also, and this is kind of what I showed before with the hypertension, you want to make it very clear for the reader what they're looking at, right? What so in this example, stigma and disadvantage was a factor in what was studied, right? And so rather than having the information presented like this, it's presented in more of a sequential fashion from 0 to 16 plus, in going down rather than up. And it's also emphasizing what is really striking about this data, and it's taking out extraneous backgrounds. Here's just another example of how orientation of what you're showing is important as well as color. I very often will create graphs that look like the one on the left, and I have to remind myself that that is going, for someone who's looking at the information for the first time, that is going to be almost impossible to digest. Right? Excel and a lot of other data visualization packages have many features, many bells and whistles, so to speak. But you don't always need to use them. And in some cases, more of the features are less useful. So generally, it's overkill. It's too much to use the 3D chart feature, although there may be times when you want to do it. Um, And keep that in mind also. As people tell me all the time, simpler is better. Um, but you also need to balance that against what you know about the data so that you don't oversimplify it too much. Usually, a 3D versus a flat bar graph is not going to really make a difference, except to make things busier and less visually appealing. Um, Another thing is if you are comparing charts. So, for example, on the left, maybe you have a chart from one region and on the right another. You not only want to keep the colors consistent, but you want to keep the styles consistent so that once again, the differences between them can jump out almost immediately. Um, there are times when you definitely want to use a pie chart, but you may want to rethink that if you can, because as shown again here, it is much more visually understandable to use a bar chart. I still use pie charts, especially for waste composition. Um, and it still can be a useful visual, but when you start to have a lot of categories, as we saw before, that's when the pie chart really starts to break down and not be a good data viz object. Another important feature is to start your axis at 0 unless you have a really good reason not to, which you should explain. Because if you do not, it's going to exaggerate differences that may not really tell the whole picture. So in the graph at the left, it would seem in just at first glance that B is doing very little in comparison to D. And that is true, right? But it's not as marked a trend as this graph makes it seem. There was a book that came out many years ago called How to Lie with Statistics. And it was all about how using statistics and presenting them in different ways can be used to mislead readers. And one of the ways was to play around with the x-axis. I'm sorry, the y-axis in a method like this. So some common mistakes in data visualization are if percentages don't add up, right? So in this example, this may be someone is trying to show um, percentages of people who meet certain criteria, and they're not mutually exclusive, right? So these percentages are kind of standalone percentages, and yet they're presented as a pie chart, which implies that everything is going to be out of 100%. Um, if you don't already know, I will tell you that when percentages don't add up, even if, let's say, you were aiming for them to add up to 100 and they added up to 99.5%, you will always have someone that raises their hand and asks you why they don't add up to 100. That is a very common, especially with students, it's a very common question that people ask to show that they're paying attention and that they're critical. And it's one that you can easily avoid by choosing the right visualization. Another is, once again, it's too complicated. Here we have information that is about the baby boomer generation and what they think about themselves in terms of characteristics, but you also have a whole bunch of a whole bunch of different colors going on. You have these lines that are connected to an image of a person walking that don't make any sense. Why is tech savvy around the waist, for example? Why are we looking at a person that appears to be walking? Is this supposed to be a baby boomer person? it's all very unclear. Also, the use of different fonts here, especially these more whimsical fonts, can actually take away from what you're trying to convey. Simply having too complicated a graph, and when I show you some examples of my work, you may say that about me as well. So this is something that I'm constantly fighting against, but complexity is going to interfere with your message. Another common mistake is when you are using circles to convey information about quantity, which is a good way to convey it. Don't and you want to, so it's probably hard to read here, but this says that breast cancer raised 257 million and prostate cancer raised 147 million, etc. You need to adjust the size of these circles in accordance with the relative data. And the way that you do that, often people do it by taking the diameter of a circle and saying, okay, well, maybe this one's 1, so this one would be 10, and this one would be 0.5. However, because that's not the way, the diameter is only one element of the area of a circle, you want to use the formula, and the R is going to correspond to the different data points that you have. And that way you will be able to correctly scale all of your circles, as in the example to the right. This is an example from my field. I've actually seen these graphs many, many times. Here, the mistake is that they're being put, it's a nice idea that they're going to be put on a map, but because they are put on a map, they're not on the same level. They're clustered in some areas and not others, and it's hard. And I realize this is a blurry image, also, which is something that I apologize for, and is ironically part of data visualization as well. You want crisp images. So this example here has a lot of flaws. Right? This is just another example of some mistakes. Number one, it's not really intuitive to have the 0 value at the top. We don't know if we're looking at a graph that is the white area or the maroon area. And this overall is not something that is conveying what the actual chart would convey, which is if you flipped it around. I'd like to say a few things about the data visualization of qualitative data, which is not numeric data. So when I showed you when we began that this was going to be what we were going to talk about, right? And this is a portrayal of some qualitative data, albeit very simple. What I was trying to show is that we're going to be progressing through a number of steps. I didn't want to list these as bullet points because bullet points are everywhere and boring, right? So that was my thinking. I use something called, oh, sorry. If let's simplify these and now look at them. They were created by something called Smart Art, which is another Microsoft feature in Excel, PowerPoint, and even Microsoft Word. And Smart Art allows you to make different configurations of qualitative data very, very quickly and easily, and to flip back and forth between them. So I made this, and then simply by changing the chart type, I could make the visual look in these different ways instantly without having to retype anything or orient anything. And so I would say that this is another good friend here. Um, Smart art. My students, many of whom are young and very tech savvy, often do not know about this. And so I really want to recommend it. Um, another view of qualitative data visualization is um, through some of these suggestions here that were put together by someone else, not me, Stephanie Evergreen, who has a consulting firm in data visualization. And I'm not going to get into too much about this because um, we've been going over some of the ideas, but essentially what you should be keeping in mind is that you can present qualitative data, that is non-numeric data, visually as well. You can use things like word clouds and sort of networks and trees is a way that you can't do that with numbers. You can show relationships. You can show steps over time. And you can organize information into themes and color that organ information. Here is another qualitative data visualization where uh, you have a number of methods to, excuse me, to tell a story um, that have to do with what you want to do and what you want to do it. And you may think that some are better than others, right? Um, so perhaps you've decided to highlight the best ones in the dark blue, some good ones in the light blue, and not any of the ones that are not good ideas, right? So I'm going to finish up here with a few samples from my current research. So this graph here is something that is pretty busy. It's pretty complicated, and yet I worked on it for days and days and days to get it into this state. And I it, I think it's useful. And I would love to get more feedback. But basically, what I'm trying to show here is, and just some background is in New York City, if you do not recycle, or not you, if a building doesn't recycle, the building owner gets a ticket, gets a fine. They're issued a fine. So I took the data on the number of tickets that were issued over time, going back to 1990, and that's what is shown in the bars here. The number of recycling tickets per year is shown at the bottom. And then I charted the recycling rate as the linear graph, and it shows recycling. This recycling program is just starting, and when it's finally implemented all over the city, boom, the recycling rate goes up, and then it sort of stays the same, and then it boom, it has another boom, and then it has a terrible fall, and it has another boom, and then it follows a little bit of a dip and an up and a down, right? But basically, at the end of almost 30 years, we're at the same we're at the same rate that we were not that long ago, and yet we have these dips, and because I know about the history of the recycling program, I know some of the qualitative reasons why we're seeing these rapid changes. So this boom here is not because more people were recycling, it's and then this Many of the recycling programs were canceled and then they were restored, right? And then after that, there also was a period in which even more items were added to what was collected. So these increases and decreases in the rates, they have nothing to do with tickets. So that's what I'm trying to show here. I'm working with colleagues on a more quantitative statistical analysis of the correlation between ticketing and diversion rate over time in conjunction with other variables. But I was using this to make an argument in New York City, an applied argument, because the plan is now to ticket buildings who do not separate their organic waste for composting. And I think that this is a bad idea. I can, if you want to discuss it, we can, but I think it's a bad idea mainly because the tickets don't correspond with people's actual recycling or composting behavior. They are, in fact, more of a way to get revenue for the city than they are, and to be symbolic, so that the sanitation agency can say, look at what we're doing, right? Then they are a way to actually achieve the goal that they are seeking. So this was a data visualization that I worked on. You can see with the color, I try to limit the color. And I'm trying to tell people what I want them to take away from this graph. But this is a very busy graph. The second is, again, relating to the work I do. This one I think is a lot clearer, and it's meant to make the point that despite the fact that since 2010, we have had composting programs in New York City, the amount that we have separated for composting out of everything that could be separated is tiny. It's like, I like to say, it's like the icing on a cake. And instead, the vast majority of compostable items like food scraps, yard trimmings, compostable paper is still being sent to landfill. So this is an image that when I show it to people, they're usually very unaware of this and they're shocked. And that's what I want them to be, right? I want them to be shocked by this. So with that said, I am open for questions.